Welcome to Session 4. In this session, we will be introducing 2D vector design. We will be discussing professional applications of vector design and how to start designing. This session, we will be focusing on designing SVG files. So now, you must be wondering, what is SVG? Well, SVG stands for Scalable Vector Graphics, and if we break those words down, SVG is a file that contains lines, which are the vectors. Those lines are connected to create shapes, which are the graphics, and we can resize these shapes without losing quality, which makes them scalable. These images can be created from scratch, edited from many different applications, and resized as many times as needed. To better understand vectors, we can take a step back and think about times that we have used vectors in other subjects. You might remember vectors from high school or college. Vectors are common in mathematics and physics. In the simplest definition, vectors are lines. They have a direction and a magnitude, and the line connects 2 points in space. When we start talking about vector design and vector graphics, the definition of vector changes a little. Since we are using a computer to design, we have to keep in mind that we will be working on a Cartesian plane. We also know this as a coordinate plane. Thus, graphics are images that are located on a coordinate plane. These graphics are made by connecting lines and curves to form shapes. Since we have mentioned that SVG is a file, let's clarify what files are. We have been dealing with physical files our entire lives. A physical file can be a folder or a box for holding loose papers. We usually arrange and organize them in a particular order for easy use and reference. When we start talking about computers, we refer to these files as digital files. Similar to physical files, we use digital files to record and keep track of data. Just as words can be written on paper, we can write data in a computer file. Digital files store all kinds of data. We can store text, images, videos, a combination of all of those, and even scalable vector graphics. When we are dealing with digital files, we have to name them, and in addition to that, we have to declare a file extension. When we work with digital files, we have to name them so the computer can understand and organize them. But did you know there is a whole study about effectively naming your files, and for today's lesson, we will cover a couple of tips. To start off, your file name should be short but descriptive. Think about the file name as a title of an essay. It should be less than 25 characters long. Additionally, a file name should not contain any special characters or spaces. Underscores and periods are allowed. Now, in addition to naming your file with a short descriptive title, it should also include a version number. Versioning is very common amongst engineers, architects, programmers, designers, and even anyone who creates multiple versions of the same project. The only factor that is constant in product design is change. While we develop our projects, it is important to keep records of our constantly changing design. So we should take a copy and create a new copy of our designs every time we plan to make a major change and version it accordingly. This will help us keep track of records of all of our earlier versions of that same project. Now that we have talked about digital files, we mentioned that all files must have a file name in addition to a file extension. So, what is a file extension? Well, a file extension is a group of letters occurring after a period in a file name. Before, in the previous slide, we talked about naming our files with a short description in addition to adding a versioning. But that file extension is going to come after that name and that version number. So, when we are watching silly cat videos online, we're most likely looking at a .gif or a .mp4. When we take pictures, we are creating a file with the extension of .jpeg or .png. When we write an essay, we are creating a file with the extension of .doc, like document. or .txt. Similarly, when we are dealing with vector graphic files, we will have the file extension of .svg. Now that we are experts in SVG and we know that an SVG file holds vector graphics, we can now talk about some professional applications for this type of file. Graphic design is the most popular application for businesses. Professionals can make logos, posters, banners, and flyers for events. Learning how to create SVG files will be an advantage when marketing a new business or product. In this session, we will be learning how to use Inkscape. This is a free software we will deep dive into and master. In addition to Inkscape, there are many other applications online, such as SVG Edit and Adobe Illustrator. If you would like to learn more about SVG design, make sure to look out for the logo in online resources. In addition to digital applications such as logos and custom designs, we can actually use SVG files on machines. In previous sessions, we learned about laser cutters and CNC machines, and it turns out that both of these machines are compatible with vector files. These two machines can cut and engrave designs into physical materials with additional preparation. When we are thinking of creating a design and using a machine to make it physical, we first have to start off with step number 1, which is the design itself. We will need to use a design software, and in the design software, we will be designing our own scalable vector graphics. In this case, we will be using Inkscape. After we finish our design, the SVG file will be imported into another application. This second application will actually translate and convert the design into instructions that the machine will understand. These instructions are called G-code. Finally, we will set up the material we want in the machine we have chosen, and we will import the G-code file into the machine itself, keeping in mind that the machine has its own software to control all the components in the machine. The CNC machine and laser cutter use the process of subtractive manufacturing, meaning that the machines will cut, drill, and remove material from the design. Keeping this in mind, let's discuss some advantages and disadvantages of this process. One advantage is that there is a wide selection of materials available to be used by these machines. In addition to that, the machines have precise control and a clean surface finish. A lot of detail can be made by these machines. Lastly, since the machines use specific instructions, it would be really easy to recreate and replicate the same design as needed with the same outcome. Some disadvantages that we should keep in mind are that since the machines take away material, we will waste whatever material is removed. In addition to that, we might face some design limitations because the machines might have problems creating elaborate geometric designs. Finally, in order to save money and reduce errors, we will have to spend a lot of time designing, planning, and selecting the correct materials to achieve our final product. These factors would be crucial to the development of your product or design.